Hello everyone, welcome to Sales Office Hours for May 30th, 2024. We have some items in the agenda. The first one is from Bishwa, who's not on call, but I'll verbalize for him. He's asking if he can run JDK in cell mode to test locally. And the reason for that is because the fulfillment team needs to start sending internal calls to a GitLab instance so they can set up customer dot as expected. Tonk, I think you have the correct answer there.
Yeah, so for now, you can use the POC, and there's a link to the POC repo there. So the POC repo is basically you spin out two GTKs, and then there's a simple router to switch between them. The actual router and the topology service is still in development, so we don't have the ability yet. Yeah, so use the POC for now.
Cool. Jarv, you have the next item.
Yeah, I don't know if it's anything to discuss here. Just I was wondering what the SSOT was for the schedule/timeline. It seemed like things are pointing to this epic, but okay. It sounds to me like maybe there's something else being developed as well. So
Yeah, I think it's a work in progress. Last time I talked to Ethan, he's still trying to get a good Gantt chart, and hopefully he'll leave it in the time projection part. And I also know Jerry is working on dependencies on each work stream and each phase that he's looking into. So I think it's still something that they're working on right now. I know from the fast boot, Jerry's target date was 1st of June to set something up. So maybe we'll hear from him in the next week. So yeah.
okay, and the context for this is, yeah, it makes sense. So the context for this is that I'm just kind of curious as to when certain things are going to land in infrastructure, and that would be like, I don't know, the dedicated runners, the I guess like sales topology service and runway, these sort of things. I think like we're probably going to deploy in staging first, but I'm missing maybe this is more of a fine-grained kind of thing. But
I think that's what Ethan and that's what Ethan is and Jerry is working on, right? Like the dependencies and like what's gonna come first. And Alessio shared the doc that Jerry is working on there as well. But yeah, you're right. Like I don't think we have a clear, like at least specifically infrastructure. I think the application is in a better state, but infrastructure, we don't have a clear timeline of like when we're gonna do what, or like specific dates when we're gonna do what. So I think it's still a work in progress at the moment.
oh, okay. I think that's fine for me. Traba, are you on? Yeah.
Yeah.
Hey.
Yes, sure. Yeah, my question is like I've been like working to finalize the logic on how we can generate a cluster-wide unique ID sequences. So I'm trying to like split the 64 bits in a way that we can use it to generate the unique sequences across all the cells. And as part of that, we had a discussion, and Tong rightly raised the question that because initially I in the solutions which were suggested, I blocked 12 bits for the cell ID, and it can accommodate up to 4095 cell IDs, unique cell IDs. And yeah, just wanted to bounce this here to get your opinions, and also like I was wondering what are the scenarios we will end up decommission a cell so that the cell ID can again be used for other cells. And yeah, so the question is, what do we have any answer for what would be the maximum number of cells we might need?
I don't think we have a maximum number yet, simply because we don't know how much we can fit in a cell, and this is because each cell will depend on the user and the workload it has in it, right?
Yeah.
So right now we're using the reference architecture, and those reference architecture, we're saying 50K reference architecture, right? And 50K means 50K users.
Yeah.
But we could, we do envision having a 50K reference architecture, but not having 50K users in there, like only a subset of users, simply because their workload is heavy, right? Imagine a large mono repository. So I don't think we have a specific number. Like the only indication we can say is like we divide by 50, right? So if we have, I think Alexander did this. If we have like 16 million users and we divide it by 50, that turns into like 3,000 cells or something like that.
Yeah, around that.
So
I
we
think
could
300.
try it 300, yeah. So we could go in that direction, but again, it really depends because like we have 16 million users, but I doubt all of them are active, right? Like maybe a subset of them are active. So regarding decommissioning a cell, it's still too far early to know when we're gonna decommission. The only one that we might decommission and recommission multiple times is the cell in ring 0, which is the QA cell. That's good, we can destroy at any time, or at least that's the idea, that we can destroy at any time.
But I think it's also important on the decommissioning aspect that when we go for the testing environment, it would be much more likely there to actually create and decommission cells. So if it's something that is supported out of the box and then require extra handover around to make sure that the test environment keeps working, this will be great.
Yeah.
Sense. Yeah, thanks for that. Yeah, we wanted to be very sure of this because this is more like a one-way decision. So once we deploy this, we can't easily increase the cells that we can accommodate because it will only have like 12 bits.
If we ever,
yeah,
let's say, so the idea behind cells, at least from the way I know it, is this is gonna be the architecture that's gonna run for the next 10 to 15 years and will give us scalability headroom, right? So if we're saying that we can only have 4,000 cells in the future, and we're saying, oh, the current users, if we just go into a 1-to-1 ratio, will fill up like 80% of the 4,095, because we're going to go with 3,000 cells, right? Are we giving ourselves a bottleneck, or do you think this is something just a temporary measure and something that will change in the future? Like, I'm curious if this is just going to give us runway for the next 5 years, where ideally the cells should give us runway for the next 10 years. That makes sense.
Yeah. To answer that, it's not something which we can change after it's been in production because we will start moving the organizations and at that time the IDs will start to collide if the bits are not properly allocated. Yeah, so it's like it can't be changed, I fear. Yeah. So in that case, maybe we can of course like try to come up with other ways to do this. Maybe allocate 13 bits for cell ID so that we will have like enough number of that will give a huge range, and we can work on work with other bits left over in order to see if we can generate a unique sequence. Yeah.
Well, I guess I haven't really fully read the issue, so these are shallow questions. But like, what are the drawbacks of using higher bits so we have a higher number of cells?
Actually, increasing one bit will give us, I think, double the number of cells to support, but it will reduce the remaining bits in the 64 bits. So from 64 bits, now we have, for example, like having a simple solution. Let's say we are leaving, so one bit in the MSB is already used for signs, and if we are using 13 bits, we'll be having 50 bits left to generate the unique sequence. So that's the only drawback. So each table in the cell will have like 2 power 50 minus 1 unique IDs to support. And if we reduce it here, then it will have like 51 bits to accommodate. But that's one solution, which is the solution 1 in that issue. Solution 2 is slightly nuanced, like we try to use timestamp there. So that is where the crunching of IDs slightly eats up a lot of possibility of the other bits, because from 17 bits, it will reduce it to 16 bits of unique IDs per table per second. So for every second, we can give at max like 2 per 16. So we have to work it out and see whether that's acceptable. But that's the trade-off what we are talking here.
Okay.
Yeah.
So to make sure I understand, if we go with 13 bits, we get higher unique cell IDs, but then we get a smaller range of unique IDs on, for example, project IDs, right? Because we're
that's
using
right.
more bits in the 64-bit space. Okay.
Yeah.
And that would be so 64 minus 13. So if we go with 51, how much is that? Like how many IDs is that?
So 2 per 51 minus. That's a lot. Let's see. I think
It's like even if we go 50 bits, yeah, even if we go like 50 bits, like so we allocate 14 bits.
Yeah.
We like 50 bits seems quite a lot, and this just might be my naivety talking, but if we implement like 50 bits for unique IDs for like project IDs or like CI builds, and then implement also the retention policies that we've been talking about for ages, like deleting old CI builds, vulnerabilities, and things like that to free up IDs as well. It might not be that big of a deal, but again, this is just like my naivety talking, and like it might not be. There might be some intricacies between that. So
actually, with 51, yeah, with 51, we can already support like 2,251 billion IDs. And that's with the solution 1 in that issue. And yeah, I think solution 1, it's also like easy to implement, but the only thing is then we have to think more on how the decommission works and how we are going to handle in the topology service. Because there are 2 solutions which is being discussed. The first solution gives like 51 ID range, so that can very well be reduced to 50, and we can increase the bits for supporting the cell IDs. But the another solution which is slightly more easy to implement in a way, like we don't have to like worry about many other things, that is giving just 17 bits of ID range. So in order to like reduce that's something which I have to spend some more time and getting all the implications that might live with this. Yeah, but thanks for the thoughts. I'll take that into account.
Yeah. And the cell IDs, they're just to keep global uniqueness through all cells, right?
That's right. Yeah.
Yeah. And do you like, and I'm just thinking, do you ever envision us moving away from that, or do you think this is just going to be a fundamental part of how cells and IDs work in general? Like,
I think it's
do you
going
ever
to.
see? Yeah, go ahead.
Yeah, I think it's going to be an integral part. Like, at least
Okay.
I can't think of a way where we can come out of this. Because with the cells coming into play, I think we will be sticking with this to generate the IDs.
Okay.
And how does it
Yeah.
work when we have the cell mover? So are we going to reassign IDs on every entry because this is the new cell?
No, actually, that's why we are trying to have all the IDs, all the sequence in any cell to be unique across the cells. So it's going to be cluster-wide unique. Even when we are moving the args between the cells, it's again going to be unique.
So it's not marking the location of a data, but is marking the origin when it was first generated.
No, it. What do you mean by marking the origin?
Yeah,
Oh,
I
yeah.
mean, if
If you're going to like,
entry,
yeah.
so we take an
Yeah.
entry and is ID.
Mhm.
So if we don't have the mover, the
Yeah.
ID can correlate to the
That's
location
right.
of that data, right? Because it's the bit represents the cell ID that generated that data. Once we have the mover, there will be no collision by moving that information to another cell because of the ID things. But then, if we just look at the row in a database, it will not tell us where the information is located. It will tell us where the information was generated the first time.
Yeah, that's right. So ideally, we should not rely on or we should not try to get the cell ID out of the ID and then try to make sense out of it, because it's just, as you said, it's the originating cell.
Okay.
And again, after moving the args to a different cell, the IDs won't be ordered because it will be like coming from a different cell. And let's say there are like 10 projects and 5 projects are coming from cell 2, but created later. But since it's like from cell 2 and if it's moved to cell 4 or cell 3, that will be like before those records.
Okay.
Yeah.
Thank you.
And yeah, so that's the reason why we are also like putting the other solution in that issue out in the air, because it uses the timestamp as the MSBs or try to represent the timestamp, so that even if we move between the cells, the IDs will be ordered. But again, the cell ID can't be trusted there at the originating cell. Yep.
And the timestamp generated one is kind of mimicking what a ULID will look like, right?
Yeah, with just less number of bits.
Yeah.
And
Okay.
yeah.
Do we anticipate changes to order by ID across the app because of this? Because when you move, it can be problematic when you order by ID.
Yeah. I think our idea is to see if we are going with the first solution, which just as cell ID and the 50 bits of or 51 bits of sequence, then we have to identify all the places where we are relying on order by ID and try to fix them to not do that. Yeah.
And I guess the biggest con of the timestamp one is like we'd have to rework all the IDs as well, right? Or am I misunderstanding it? Like, for example, project IDs, will we have to rework how project IDs get generated?
I mean, for using the timestamp logic?
Yes, solution 2.
No, with solution 2, we will already have the order, but maybe I'm missing something.
Or no, maybe I'm misunderstanding timestamp. Okay. So, like, how would a project ID look like with timestamp?
Yeah, with timestamp, let's say it's based on at what time we are generating it, and it will be having with the 34 bits, we thought of having a seconds precision time. It will have that particular second, and then the cell ID, and then 17 bits of
Got it.
sequence.
Okay.
Yeah. So even if we move the project between cells, since it has the timestamp, so it will be like ordered within that second. If there are like multiple projects created in the same second, yeah, we can't like make it chronologically sorted within the second, but we can also like increase that bit. Let's say instead of 34, if we have 35, or we can also like try to store micro or millisecond or 10 millisecond precision instead of second precision from the epoch or any time which we set. So there are some trade-offs. If it's seconds, we can have this running for another 540 years something. But if we like reduce that to 10 millisecond precision, then instead of 500, it would be another 170 years. So
Okay.
so yeah, all the levers have an impact on the neighboring items. Or yeah, it's more like adjusting the lever and then choosing what's best for us.
And solution one seems to be a two-way door decision, right? Because if we want
Yeah.
to go to timestamp in the future, then we
Yeah.
can switch to timestamps for like new cells, for example, and then yeah, okay.
Yeah. And solution two is something which is being popularly used by other companies as well. I think they call it Snowflake. It got introduced by Twitter a long back, and then people are like doing some tweaks to it and then adjusting on how it works for their needs, and then having a version of that. And this is just another version of that. Yeah, thanks.
So coming from this discussion, what do you think would be the best solution in your opinion?
Yeah, I think based on our discussion, solution one seems like the robust one. Like at least it gives us more options to play with. And yeah, that also like gives a breathing space for us on the number of cells to be supported. But the only thing is we have to like the ordering is not preserved and we have to work for that. And the topology service should keep track of how the decommissioning works, because we can't reuse the cell IDs in this.
Yeah, I remember in the fast boot we talked about leasing the ID, right? Because like leasing it as a temporary rather than allocating it, because we want the ability to decommission. And
Yeah.
like I could see us where we can like, and there's some ideas that are just for you to keep in mind where I see us decommissioning is we might want to move to let's imagine, right? Like let's say we're using Cloud SQL for GitLab.com in production and we have customer data there, and we want to go to another offering of Postgres SQL, right? Like one way we can implement that is using org mover, where we move the organization from the old infrastructure to the new cells, right? So we might need to decommission a bunch of cells, and Postgres is just an example, but we might end up implementing some of that for other reasons, right? Like how we set up, I don't know, VPCs or like some other one-way door decision that we made that we have to fix. So we need to have the ability to drain a cell and decommission it. So I think if we try to optimize for that from day one, as Alessio said, it'd be really useful for us.
Yeah, sure.
I was reading the issue to actually better grasp the proposal 1 and 2. So I have a question, because I think that we are kind of diverging from the mental model that we had during the fastboot. So maybe decommissioning is no longer a big issue. So I'm just gonna bounce some ideas just to figure out if my understanding is correct, right? So we went into the fastboot thinking of leasing the right term, sequence of IDs. So a cell show up, has a number, and ask for sequences for all its tables. And so there is a central service, a topology service that is loaning sequences. And those are just sequential. They're not assigned by most significant bits or things like that. This is your slice, okay? And so at that stage, we had this issue where if we are going to create a cell, this will basically eat a slice of the global IDs for every single table. And if we destroy it, those slices are lost forever. So that was the thing, that the conversation we had in mind at that point. But if I'm reading correctly the issue, and I'm just reading as we were speaking, we're doing a different thing here, which is a cell as an ID. And this ID fits into the most significant bit of every ID on every table on that cell. And so there's no leasing here, right? So basically they can self-generate autonomously the every IDs, assuming that there is a agreement on the uniqueness of that cell ID. So if this is the case, I think that what we want is just a system that makes sure that the cell ID is unique globally, and something to say this cell no longer exists, so that we can recycle. Because
isn't that the same thing you just explained though? Like if
no, because
if we're leasing a cell ID and we're freeing it up, then it's the same, right? We're still blocking.
It's a bit different. So initially we're talking about reclaiming unused IDs. Now the thing is more about cleaning up non-existing resources. So when you decommission a cell, what happens to the globally available IDs that were generated there? Because this is no longer a sequence of things now. It's just you have the MSP, but it is no longer those are slices and these are empty, these are full. So I'm wondering if there is a way to actually know what was lost in the destruction of a cell, because you don't know. Maybe we decide. So if we tear down a cell, it doesn't mean that we go through the cell and delete every single project users and things like that, right? So how do we know what survived this process? And if we know, is it possible to actually reassign the same cell ID to a new cell? Will it actually create, especially with the timestamp approach, will it actually, because time can't go back, that's kind of an important assumption. So is it actually possible for a new cell that claims the same ID of an old existing cell to generate conflicting IDs? Because if this is not this is not possible, maybe the timestamp is the right approach, because it removes the problem from decommissioning. It's just a matter of cleaning up things that no longer exist, that are no longer referenceable, which is a different problem.
Yeah, thanks for the question, Alasho. Like, I think there are two parts to it. The first one is with the timestamp. Of course, we don't have the decommissioning problem because the time always runs. So whatever happens in the future, it's going to have a new ID. So that's clear there. But with the first one, which is giving a huge range of sequences to deal with for each cells. So how I see there is, yeah, you are true that this can be done by the cell itself if there is a way to make sure that cell ID is unique for the cell. But how I viewed this is ideally the min value and max value for the sequence will be given by the topology service to the cell on provisioning, because let's say the topology service is using, or the cell itself is using the MSBs with the cell IDs. It's just a way of allocating a range from the globally available values. So it's just like trying to split that, but using some logic to it, because it needs some logic in order to like split it. It can be like adding a cell ID or just saying that, hey, take the first 200 billion IDs from there and then give it to the first cell and next 200 billions. But if this was given by the topology service, then the topology service can have a list of all the cells and what are the maximum value, minimum and maximum value it has given or leased currently. And when the cell is decommissioned, the cell should inform the topology service that at the time of decommissioning or before decommissioning, this was my maximum. Yeah, this is my maximum value, which is being used till now. And again, there is another level of questioning to this, because since the sequence is for each table, there can be project table, which is like highly used. The maximum value on that can be way more than the least active table. So we might, in order to like properly avoid any gaps, or in order to use the IDs fully, we might have to, the topology service might have to like give the minimum and maximum for each table in the cells, but that's slightly a lot of work, because whenever we are adding a new table, then we have to reach out to the topology service in order to get the range of the sequence. If we can live with just having the maximum value for per cell, and then say that all new tables created for the new cell with the same cell ID, because this range will only get reused only when we are going to like use the same cell ID. For example, let's say we are decommissioning the cell 1, and of course we don't want to like just ghost it, so we want to like again use it. So that's the whole idea of leasing. So I think the term leasing can be used for this approach as well. It's all based on who is going to give the value. So if this is there in the topology service, and then I can see this as leasing. But if the cell itself is going to generate, then it's not a leasing anymore. It's just generating itself, and the third-party service has to maintain the cell uniqueness. But yeah, that's the parts which we have to think for solution 1. But I think it can be pulled off. Yeah. Hope that answered your questions.
Yeah,
Yeah.
it does.
Okay.
Thank you. I'm thinking, generally speaking, even if we remove cells from the project, from this problem space, right? So reusing IDs is problematic in general, right? So if you just have a table that is approaching the end of the table, and you cleaned up, so you have olds because you deleted stuff, right? So is there actually a practical way to fill those IDs back? Because we usually with RAIDs we're using sequences, so we just keep going up and up and up. So is there actually a real way to fill back those values?
You were saying when the actual project record is being deleted, or when the
Yeah.
cell is, I think we will be having that problem in our current database as well, right? I think it's just gone. I don't think we will be reusing it, because the sequence is always incrementing by 1.
Yeah, that's my point, right? So I think that we're just making this problem more evident here, because by adding cell IDs, timestamps, we're just shrinking the number of bits available to the cell. But so it doesn't look like reusing of IDs, but it's just, as you were mentioning, keeping track of the maximum value that was already used by whatever is the sharding key that allows you to give IDs out to that cell, and make sure you continue from there. So I think it will be very unlikely for us to find a way to go back, unless we have a long sequence of things that we know were deleted, and we have a new cell, so we can kind of give it this huge slice as a new sequence to a new cell. Yeah, it makes sense. So thank you for explaining.
Sure. Thanks.
I've got, so Camille suggested reusing the cell ID in that link. So one thing, I think that's sort of speaking against approach too, because that's kind of working around the 4,995 limit, and it's risky because like we cannot trust computer. I don't think we can trust computer clocks unless we use atomic clocks. like Google does. So like you definitely need a lot of buffer. So I think that definitely is something to think about. And then the naming of it as well. I don't know of a better name, but it's not really the cell ID, is it? I don't know, because if we, especially if we start to reuse it, right? Because like let's say today there's cell ID 1, it's this thing, and then 10 years from now something else that's not on GCP maybe. Now Flying Spaghetti Monster Cloud also reuses cell ID 1, but they have the same ID, but it's not really an ID. It's just a identifier at this point, right? Yeah, so I don't know. Maybe what I'm trying to say is that I think maybe a better name for it would be helpful as well to think about it. Yeah.
Yeah, yeah, totally understand that. Yeah, because the cell would be like 100 or 1000 cell, but it can still have cell IDs too. Maybe it's
Yeah.
more like it's more like living cell ID. Yeah, I don't have a better name, but yeah, we should think about that. Yeah, also each cell is a living organism. I don't know about making the cell dead. Pun intended. Yeah.
Awesome. Is there anything else we want to discuss? Any other items in the agenda? Cool. Have a nice day, everyone. Thank you for coming.
Bye.